Okay. On the AP test, you will have one of your 6 free response questions that will either be parametric or polar. Every time. Okay? So when we get AP problems that are parametric, they're really these vector value functions that we think of parametrically. Okay, so today we're going to put it all together AP style. Okay, so let's talk about things that we remember from motion back in AB.
It has to do with movement.
Yeah.
Derivatives.
Okay, so the derivative position is velocity. The derivative of velocity is
Acceleration.
okay. The magnitude of velocity would be
The impulse.
No.
No. Was that the integral of
force times
what was the area? Like the area of
It was
the graph was
difference in
something.
momentum.
I swear.
Change in momentum
Momentum
and
impulse related like that.
okay.
Yeah, change in momentum is force times.
Yeah, these don't involve mass.
We knew Mars.
Displacement. Displacement. We can take the integral of velocity on a given interval, right, to get displacement.
I'd have to concur.
And then distance, well, now that we're in parametric, we've talked about arc length, right? So arc lengths can be interchanged with distance. Would you agree?
Very well.
Okay. Now remember, we are talking about vector valued functions. So when we find the velocity vector, we actually have like the tangent vector to the curve, right? When we take the derivative, we have a tangent vector. In motion, which is really the point of parametric, okay? In motion, that derivative would be considered our velocity, okay? So we're just going to practice working with our vector value functions, but now in the context of position, velocity, and acceleration. Is there something you'd like to?
I just realized that sentence says, "Do we remember?" And I don't know what rectilinear motion means. What does that mean?
Rectangle.
So back in AB, we talked about a particle moving left and right, or up and down. Okay, so it just moved along a line, linear motion, rectilinear, like linear motion. Now we're talking about a particle that can move in all sorts of directions. Okay, so we describe it parametrically, so we can talk about the horizontal and vertical components separately. We couldn't do that last year. We could only talk about left, right, or up, down. Now we're talking about left, right, up, down, all at the same time.
Are we supposed to say no sheet, or is that for you?
So I'm actually not going to give it out right now because your homework's on the other side, and I don't trust every single one of you not to start your homework while I'm talking.
That's pretty much just me.
And
And Matt.
I think it's more than just those two. Okay.
Well, yeah.
And then, right.
Well,
I
feel like
we all are.
Some kind of movement.
I don't see why.
Alright, storm the home.
You can't stop us all.
Someone gave you a look, man. I think she can stop us.
Okay.
I just don't know.
Okay, the position of the particle is this. Please write it down. The position is described by this.
Oh my. Very good examples.
Must have been like grammatically correct.
Yeah, it doesn't matter. But I don't think so.
What do you? What would she? What words would
You need close with parentheses.
That's a big parenthesis.
This
is moving pretty fast. I got
town size?
Okay, but that's actually a really
I
good
told
point.
you that.
Okay,
For
so
both
on your
sides.
paper, I would write velocity vector at t equals 1.
That's right.
Velocity vector at t equals 1. Okay, not all the time will your position be given to you in a vector. Okay, but if we made this a vector valued function, we could say, okay, our position is the vector t cubed plus 4t squared t to the 4th minus t cubed. Okay, so right now we're talking about the velocity vector. So first we need the general velocity vector. Zane, what is our velocity vector?
3t squared plus 8t, comma, 4t to the 3rd minus 3t squared.
Okay, so that's our velocity vector in component form as opposed to i's and j's, it doesn't matter. Okay, so if I want the velocity vector at 1, then all we have to do is plug in 1 to get the vector 11, 1. Okay. Now, as you recall from what, a week ago, when we talked about the speed, did we talk about speed? Now everything's all like meshing together. Have we talked about speed?
I think the word speed was mentioned.
I
at least one
definitely
time.
remember
Yeah.
that.
Go back
We
to
did.
it.
Okay. Thank you. Okay. So speed, you know, you like can't remember what you talked about. Okay. So when we did speed, we did the square root of dx dt squared plus dy dt squared. Yes? Okay. Well, by finding the velocity vector, we have dx dt and dy dt. And since it's in vector form, when we find the magnitude, we take the square root of dx dt squared plus dy dt squared. So if I want the speed of the particle, less work, I can just find the magnitude of our velocity vector. Because the magnitude is doing the same thing as that speed equation we had from before. Okay, so if you didn't, please label it as speed at t equals 1 so you know what you found. Okay, and then we're going to find acceleration vector at t equals 1, so that's the next thing you need to write down. Acceleration vector at t equals 1. Okay. Haley, what would our acceleration vector be?
12T.
Yep, forgot my t. Okay, good. So our acceleration vector at 1 would equal 14, comma 6.
That's what I got. I have to agree with everything that's just stated by everyone.
Trying to decide if I could get this quative for you. Should we try it? What mode should we be in?
How easy do we want to make this for ourselves?
I don't know.
Is it radiant?
Do you see any trig functions?
No.
No.
Doesn't matter.
This time it doesn't matter, Richard.
I don't think
This time.
I'm thinking once to start.
It's slow, like really slow,
I think it's angry.
terribly slow.
Very angry.
It's an angry guy.
Oh my gosh. Okay.
There we go. It's okay, let's
It's
let
been making your blood sacrifices to the calculator lately, so now it's just gonna be stubborn.
Am I in parametric? Okay. So y
How it works.
is t cubed plus 4t squared. No. Squared. No. Cubed. Plus 4t squared. And y is t to the fourth minus t.
What zoom do you want us to do?
I don't know.
Zoom 0.
Well, if this is describing motion, we want to start when t is 0.
Oh,
That would be the most important thing. Okay. Why?
That's a cube. Okay, so it's just okay.
Now, what coordinate would we be at when t equals 1?
Was it 5, 0? 5.
Okay.
5,
Oh,
0.
But do we know that?
How do we know?
Like, what if it is? I'm in agreement with that.
She said it doesn't matter.
so there's our velocity vector.
Yeah.
Okay.
Sure.
Okay, 11, 1, plotted right there. There's our velocity vector. Okay. Okay. That didn't make us think very much. Okay. Please write down that dx dt is t sine of t and dy dt is cosine of t squared. We know that at time equals 2, the object is at the position 1, 4. Please write that down. You know what? I'm just going to hide this off here. Okay. Richard, do you see how it says calculator permitted? Or just says calculator?
Which means
You can use your calculator. And I see trig functions. Therefore,
Degree mode.
no. We need to be in radian mode. Okay?
Cosine of t squared.
Exactly. There is not a way for us to integrate cosine of t squared, which is why we have our calculator. Okay.
I like trial and error.
Do you have written down the position at t equals 2 is 1 to 4?
Yes.
Okay? Your position will probably not be given to you in vector form. It'll most likely just be coordinate form. All right, we ready?
Let's get this.
Okay.
This bread.
Find the acceleration vector for the particle at t equals 2. Now, do we have our calculators in our hand?
I do.
Well, okay. Should we have our calculators in our hand?
I'm in agreement with that.
Big old note.
Okay, I'm not being literal. We have our calculators,
And
correct?
so, you don't want them in our hands?
No, I want it. We have our calculators within reach, whether it's in our hand or on our desk.
Lay flat
Lay
on your
flat
desk.
on your desk.
How do we find an acceleration vector if we have the what is that?
That
What
was-
what do we have?
That was
That's
like the
the first
derivative.
Which represents what about our motion?
Velocity.
Okay, technically we have the velocity vector. Could we, since we want the acceleration vector at a specific time, what can we use in our calculator to help us?
Nine.
8.
Right?
We're finding the derivative, not the 8.
I only know.
Please do math 8 2 different times.
Ooh, what? How do we do that?
Because that's the
Just type
property.
something twice.
Because we need the horizontal component separate from the vertical component.
Make sure you're in radians.
Are you sure?
Wait, it says t equals t. That's right. Then I'll plug it in.
What?
X equals
T equals 2.
Oh, I got a.
Why did you see?
I didn't know it was
Okay.
like point
0.07.
7
Seven.
7.
Oh, I got that. 0.
Oh,
Oh my god.
I was just I was evaluating because I already found
You found the. That's okay. There's not a problem with that.
But
Another one.
So math 8 cosine of t squared at t equals 2, and we get. Same.
3.027.
Get lunch next.
0. 4. You've been practicing for your roll. 2.
Just pull the ropes.
Okay,
Mr. Need was kind of.
are we okay with this?
Peter, always. Never mind. I'm not going to talk about that.
No, not for right now.
Not talking about that.
Okay. I want the equation of the tangent line to the curve at the point where t equals 2. So on your notes, write tangent line at t equals 2. What 2 items do we need to write a tangent line?
slope and
Slope and a point. What do we know already?
Point.
We know that the point is 1, 4. We now need slope. Caleb, how do we calculate slope in this situation?
One slope. Find the derivative and plug in the point.
In
Find
this
the tangent
particular
line.
case. In
And
this
then-
particular case, look at what we were given. We were given dx dt and dy dt. Do we need to take a derivative?
You just plug it into those two.
But that's 2 numbers. I want 1 number.
But that's like the 2 derivatives of both.
Okay, so how do I get 1 slope?
You put them together
How?
by dividing them.
In which order?
dy over dt over dx.
Thank you. Okay, so we can plug 2 into dy dt and dx dt. And remember, our slope, dy dx, is dy dt over dx dt. Okay, so plug in 2 to those individually, and we want dy dt at 2 divided by dx dt at 2.
Radians, make sure your radians.
Is it just me or Richard sometimes a little passive aggressive?
Not anymore.
I am.
No, you're just sarcastic.
If you crack it, it makes a weird shape.
You've never
Wait,
been
I-
sarcastic?
No, I am sarcastic. I'm having a weird day. I'm running off.
Okay,
Are you
what'd
sure?
you get for
how much
this?
sleep?
0.
Zero.
Did you?
Beat.
Divided 2. Wait.
Why'd you get
Why are you
0?
taking a derivative?
I was still on that one. I haven't started this.
Okay, Nick, what's our slope?
Negative 0.36.
359. Yeah, that's right.
You
got it
You just wanted to do that to be different.
Nick? When I asked Nick to answer, I was like, Nick. Okay, next.
When will we
It's
achieve?
a crown. That's a
I
crown.
would like the speed
Crown.
at t equals 2.
That's a crown.
So in your notes, write speed at t equals 2.
I'm gonna, I feel like it's just ignoramus.
Okay? Don't write this down, but remember from a week ago that speed is dx dt the quantity squared plus dy dt the quantity squared. Okay? We have those already. So if we want the speed at t equals 2, then we can plug 2 into t sine of t, and we can plug 2 into the cosine of t squared. And that represents our speed at t equals 2. Same thing as the magnitude of the velocity vector.
I have a question for you. Why do they always like do everything at the exact same spot? Like
What?
for everything in this we're using t equals 2.
Because they gave us the initial condition of the position at t equals 2, so everything's going to be based off of that initial condition. So that you can just use the same information throughout. Because that one force is going to come back multiple times in a
Just so for ease.
Matthew, what's our speed?
1.932 units per second.
Okay.
How do you know it's
Because that's the only time we
Okay.
Yeah,
The
try to get it.
displacement. Focus up here. Find the displacement. We know the velocity because they gave us dx dt and dy dt. So if we know the velocity,
Area of the group.
we just talked about displacement by, okay, but we're going to have to do it individually.
Math 9.
So we have the integral from 2 to 7 of dx dt and the integral from 2 to 7 of dy dt. Now I'm putting them in parentheses instead of the vectors because we're getting a position, right? It's going to be a coordinate, okay? Also, since this is a calculator problem, you can use your Math 9 command to do the integration. Bless you.
No. Yes.
Anthony, do you have an X position for us? Okay. Okay. So our X position is negative 6.362.
Wait, is that supposed to be in parentheses or vectors?
I'm doing parentheses since we're talking about, like like displacement position. Oftentimes you'll see as parentheses instead of numbers because they're representing coordinates. Okay. If you write them as vectors, it's not a problem. Okay. Caleb, what's the Y coordinate?
Well, 0.096872866.
Okay. Thank you. 3 decimal places will be fine.
There were 3 of them in there.
Pretty significant figure.
This is an AP Chem.
Yeah, thankfully it is not AP Chem. Whew.
Or
Miss Homan would not be super excited about AP Chem. Okay. I like chemistry, but I don't want to be teaching AP chemistry. How's that? Find the distance traveled from 2 to 7. So in your notes, distance from 2 to 7.
Oh, that's just the.
No spoilers.
What?
socializing.
Just say them in a way so only I hear them and Matt doesn't. And we'll be fine.
Come over
Say
here and
you're
I'll
gonna-
whisper it.
Distance traveled. We've already done this. Okay, so in the context of not motion, we're talking about arc length, right? Distance traveled is measuring how far we went on the curve. So that's just our arc length from a week ago. So as you recall, arc length is the integral from A to B of basically speed, right?
X
Is it
and then
t
X prime T squared.
sine of t plus cosine of t squared? Am I remembering the dx dt and dy dt correctly?
Yes. No, I think that's right. I'm pretty sure that's right. Wait, wrong side.
It's
You're
x prime
right.
squared plus y squared.
You're
I
right.
don't think it's possible.
Wait, what was the last?
That's
It's
part of
like-
it.
It's like 300,000.
Oh, yeah, why would that be so?
You dedicated the day, bro.
Okay.
It's a dedication.
Okay. Did you put this in your calculator? If you haven't started plugging this in your calculator, please do so
Yes.
now. Doesn't require any talking. Just requires fingers punching buttons.
That could work.
I was making fun of an inanimate object. Well, it's still not done. Why is
It's
it
still
take
thinking?
so long?
Yeah, it took a long time.
It's like frozen. It's not. I think
Haley, but you got yours? What'd you get?
13.22.
Now I want to see how long it takes.
She's using you.
Mine's taking forever.
Mine is also.
Sometimes your calculator needs to process for a little bit. It's fine. Gives you a little brain break. Okay?
Checks out.
Checks out. Okay. So this is the last thing we're going to do, and then I'm going to give you time to work on your worksheet that I will give to you. So you bombarded me.
Oh my god, that's just the thing.
Find the position of the particle at time t equals 1. Now, pencils and calculators down for a moment. Technically, there are two different ways to do this. A way we often like to do is taking, since we have the velocity, take the integral, solve for plus c's, and then plug in the value. Well, if we cannot integrate by hand, then our only option is the second way, using the fundamental theorem of calculus. Okay? So write down whatever you need to right here.
Yeah.
I'll let you pick up your pencils if you haven't already written position at time t equals 1. And what we're going to have to do, we're going to have to do the integral from what?
Yeah.
1 to 2 of our velocity vector. And we know that that's going to equal the position at 2 minus the position at 1. Right? This is the fundamental theorem of calculus. Okay? If we could integrate by hand, we wouldn't necessarily have to do this, but since we have to use our calculators, it's the only way. So we know that the position at 2 is 1, 4. We're searching for the position at 1, right? And then we need to do these two separate integrals. We need an integral for our horizontal component, and we need an integral for our vertical component. So if your last name begins anywhere from A through M, you are going to do the horizontal component. If your last name begins after that, then you're going to do the vertical component.
What if you don't have a last name?
You have a
I
last
have a
name.
last name. What if I did?
Everybody in here has a last
What
name.
if I didn't?
Well, then your first would also be your last, and therefore you go by that. It's just process of elimination.
I'll give you that.
Irrelevant.
What is?
Wait, so are you adding them together, like the two? Like when we get an answer, are we adding it to the next one?
No. Well, just
Like where
Hold
am I writing it down?
What are we supposed to do?
Oh, it's a
Wait,
point.
what is
Yeah,
it?
never mind.
Eighth round supposed to do?
horizontal.
I think that's the first one. I did the first one.
I think I got that right.
It's the answers from the
Yes.
I also don't like the, wait, what did you get for an answer?
Chris, what are you getting?
I got 1.440.
1.440.
That's what I got.
Okay.
Thank you, Josh.
Izzy, what are you getting for the y component? Okay. So now, if we want to solve for the position at 1, we would need to subtract this over to move this over, right? If I move s of 1 over here, that means I'm taking this and subtracting it over. So we get negative 0.440, comma,
Like this subtract points from each other.
there's our position at 1.
That was a lot to see. However, application algorithm.
Okay. Now, we have a homework assignment with 13 problems. If it says calculator, you use your calculator. If it doesn't say calculator, you are not using your calculator.
This is due next week.
It is due in 6 days.
Dude,
But-
Would you recommend us doing it like later then and not today?
Well, I wouldn't suggest like finishing it today, but I'd at least get started
Well, not
so that you have some momentum, you have something to look off of. But I would maybe do like half of it today and half of it in a few days.
That's not.
But
Okay, so
if you finish it today and you look over it on Sunday, that's fine too. You know what I mean?
I just gotta survive the day.
Hey, you know what? Pavilion schools have canceled after school activities.
No idea.
Miss
I
Holmes,
know, OPS canceled.
I heard that we changed our like snow day policy, so we do have late starts now.
We